This is problem 16 from the electric potential section. We have two charges separated by a distance of 4a. The charge on the left is plus 2q. The charge on the right is negative q. We want to sketch graphs of the electric potential along the lines indicated. The first one they have done for us. That is when y is equal to 0, which is on the x-axis. When you're right on top of the plus 2q charge, the potential would go to infinity. When you're right on top of the negative q charge, the potential goes to negative infinity. For each individual charge, the potential is kq over r, where q is the charge and r is the distance from the charge. And then to find the net potential, you can add the two individual potentials together. So that gives us the graph that we have here. Some important things to note are that somewhere in between these two charges, the potential is 0. Because this is plus 2q and this is negative q, that's going to happen closer to the smaller charge. And then when you're far away from both charges, the total charge that you have here is positive. So when you're really far away, the potential is going to be positive. So we are going to use some of the same ideas that we had from the electric field section to do the graphs for the potential, but I think the graphs for the potential are easier because the potential is a scalar quantity. So, and looking at the equation here, you can see that while r is always going to be positive because that's the distance from the charge to the point of interest. So if the charge is positive, the potential for that charge is positive. If the charge is negative, the potential for that charge is negative, and then you can just add the individual potentials together to get the net potential. Okay, then for graph B, y is equal to 2a, so that's along this line here. So we're graphing the potential along that line, and when I'm right here, I'm going to have a max because I'm close to the plus 2q charge. So that would correspond to like that point here, and it's going to be a max. So we'll say the potential's 3 blocks away. Okay, and then when I'm at this point here, I'm the closest that I get to the negative charge, so I'd have a min at that point. So that'd be corresponding to that point here, and I'd have a min. And I'm never right on top of the charge, so it doesn't go to infinity or negative infinity. For this charge here, the graph would look something like that. For this charge here, it would look like this. And then I add those two together. So this is a plus 2q charge. So if I did 3 blocks for this, because the distance from here to here is the same as the distance from here to here, if this is 3 blocks, because q is 2q and this is negative q, that should be half of what I had because the k is the same and the r is the same, so the potential would be proportional to just the charge when we compare this point for this charge and this point for this charge. Then I can add those two graphs together. I didn't plan that out really well, in fact, because if I add them together, it's kind of going to go off the grid a little bit, but that's okay. So it would be like that. You don't see much contribution from the negative charge when you're over here. And then somewhere we're going to get 0. It looks like from my little sketch that's going to be about here. That's probably not exactly where it is, but we don't really care as long as it's kind of in the right place. And then as you go far away, we should cross 0 again because, well, similarly to what we saw up there. When you're far away, the total charge is positive, so the potential should be positive. Let's just kind of show. There we go. Okay, so that's when y is equal to 2a. Then we want to look when x is equal to 0. So that is along this line here. Now, I think it'll be interesting or most helpful to look at what we have right at the origin. For the plus 2q charge, let's just graph the two potentials individually. So for the plus 2q charge, I'd have a max. I'm going to only make it 2 blocks this time. And for the negative q charge, we're the same distance away, so it should be negative, and it should be half of what we have there. So those are the two individual graphs. Okay, so when you add these two together, well, right at the origin you get 1, right? And then it's going to look something like this. Okay, I'm not going to like pay too much attention to this scale as long as I have my max there, and it's going to 0 on both sides as y goes to infinity and as y goes to negative infinity. Okay, so that's 16, and let's just continue on now and look at problem 17. So in problem 17, well, it's very similar now, but this is a plus q charge instead of a negative q charge. So first we look when x is equal to 0. So let's compare that to what we had in problem 16. So this was when x is equal to 0, and this was what we had for that. But now this is a positive charge. So when we look right at the origin here, let's just graph this over again. Okay, so I have the same thing for the plus 2q charge. So like that. And then for the plus q charge, now since it's positive, I'm going to have a graph like this, which is 1 block away rather than being -1. So when I add those two together, I get something like that. So it has the same kind of shape, but the max is 3 instead of 1, because now the graphs from both charges are adding together to give you something greater. Okay, and then we're looking when x is equal to 2a. Did I do that? No, that wasn't something that I graphed in the previous problem, so we don't need to look at that anymore. And so when x is equal to 2a, I am right here. And so at some point I am right on top of the plus q charge, so that's going to go to infinity. Both charges are positive, so like what we had here, the potential is always going to be positive. It's just going to go to infinity now that I'm there. So I'm not going to do the two graphs separately. I'm just going to show it goes to infinity right on top of the charge, and it goes to 0 as we go far away. Okay, then we look when y is equal to 2a, which, wait, no, yes, when y is equal to 2a, that is something that we saw previously. For problem 16, that's what we had here. And when y is equal to 2a, that is on this line here. So let's see what we had here. Okay, I had a max here, I had a min here, so now instead of having a min here, it's going to be a max. So that's like what we have here, but with this flipped around. So that will be, there we go. Okay, so that will be like this. Oops, that's the wrong one. It's this one here. So like this. And then I have a max here. Oh, is it 3 points away? Okay, and then I add those two together, and instead of getting something like this, now I get a max here and a max there. So something roughly like that. So a max for one charge and then a smaller local max for the other charge, and that is along this line here, where we're never right on top of the charge, but this is the closest that we get to the plus 2q charge, and this is the closest that we get to the plus q charge. Oh, I didn't put my charges at the right spot. I did 3 blocks away here instead of 2 blocks away, but you get the idea. Okay, so that was 17, and then we'll continue on and look at 18. And in problem 18, we have a negative q charge and a plus 2q charge, but the plus 2q charge is 4 blocks away, and the minus q charge is only 2 blocks away from the origin. we want to sketch the graph in part A when x is equal to 0. So when x is equal to 0, that is on the y-axis. This charge is positive and this charge is negative. Well, let's look at what happens right at the origin. So remember that the potential is equal to kq over r. So I'm 2 blocks away here. So for the charge on the left, let's call this v left. I have k times negative q divided by, well, let's say one block has a width a. Oh, it does, because they told us it's a distance of 6a. So this is 2a, and that's 4a. Okay, so at this point here, the potential from the charge on the left is k times negative q divided by 2a. For the charge on the right, I have k times 2q divided by 4a. But what is 2 divided by 4? That's 1/2. So that's what I have for the charge on the left. This is what I have for the charge on the right. They're going to cancel out. And so right at the origin, I'm going to have 0 for the potential. And then as I go along the y-axis here, it's going to go to 0 as I go to negative infinity and to positive infinity. And let's see. If I'm at a point up here, then there's the distance that I have there. There's the distance that I have there. As I go really far away, the distances become closer to each other, but this charge is still twice as much. So if the distance is less important, then the potential is going to be positive. And so I should have positive values for the potential. Since this is 0, I should have a max on that side. And then at the same point down here, I would have the same value. So somewhere I'm going to have a max because I had 0 in between. And I know, well, this is the only place that I'm going to get 0, except when you go to infinity and negative infinity. And because this is a plus 2q charge, when you're really far away, you'd see the total charge being positive, so the potential would be positive. So that's the graph that we have as we go along the y-axis. And then we look when y is equal to 0. That's along the x-axis. So now, looking along the x-axis, we already figured out that this point is equal to 0, so we can go ahead and put that on the graph. I have a charge here, and I have a charge here. As I approach the negative charge, the potential goes to negative infinity, so we can show that. And as I approach the positive charge, the potential goes to positive infinity. So that's what I get. Then for the last part, y is equal to negative 2a. So that is down here. And when I'm at, I feel like this is like something that we did in the last one, but with a positive 2a. So now we're down here instead of up here. We have a positive charge and a negative charge, so I'm going to get something negative on this side. That's going to look something like what I have there. Okay, so I have a charge, kind of here and here. And so it's going to be negative here. And since this charge is plus 2q, if this is 2 blocks, well, that would be larger. So 4, that would be like up here somewhere. And let's see, we're looking along the axis here. It's going to be 0 somewhere closer to the negative charge. So it's going to 0 here, crossing 0 somewhere over here, going to our maximum value there, and going to 0 as we go far away. Okay, so something like that. That gives you the overall idea. Okay, and that concludes problems 16, 17, and 18.